This lesson examines repopulating the tree view based on the radio button group and the checkbox changing. And in order to handle that, I've written a new class that's actually a new programming paradigm for anything I've discussed before. It's what's called a finite state machine, or a finite state automaton. And I reference this class at the top of the form class. It's tree finite state machine, and the object that's going to be instantiated on it is TFSA, for tree finite state automaton. As usual, this object is instantiated in the form load method, which is called at the start of day. And if we look at our before expand tree list by method, it now just calls a single function, a local function that I wrote within the form class called Invoke tree finite state automata. So I took all the code in the previous lesson and I moved it into Invoke tree finite state automata. And then I also added a lot more code that handles the finite state automata references. So this is the Invoke tree finite state automata method, and it's often called a handmaiden method because it's just something that's internal and called by other methods that are event handlers and so on. And one major change you'll notice is I'm still using node selected, but now I'm directly assigning node selected to the tree list by object, the tree list by control. And I actually didn't have to do that for the before expand method. I could have created a parameter in the invoke tree finite state automata that looked just like this. And then when I called it, I could pass the E as an argument here. But the trouble with that is I'm actually calling invoke tree finite state automata from several places. In fact, that's one of the main reasons for writing a handmaiden function, is that you're going to call it from several places, so you don't want to just duplicate the code everywhere. Another good reason is it's better code organization. It's easier to read, it's more self-documenting, and it encapsulates data a lot better. So after we assign the node selected, we create the Sql Command Object, which is the same as the previous lesson, and we assign it to the shared connection. But now in the if statement, instead of checking if the first node in the tree is a dummy node that's an asterisk, we're now calling a method within the finite state automaton class called state changed, and we're passing it the radio button for author, the radio button for type, and the checkbox in red. And if this state changed method returns true, then we execute the code. If it returns false, we don't do anything. And the reason for that is that if it's false, it means the state hasn't changed. The state of the radio button and the checkboxes haven't changed, and we've already populated the tree with the data that reflects those states, or that state. And that being the case, we don't really need to write anything out. It's already written out correctly. So this being false means the current state hasn't changed from the previous state, since we called this function. So the next major change from the previous lesson is instead of having the command text set to a fixed string variable, we now call another method within the finite state automata called getSQL for state. So we're going to have a variable SQL statement based on what the state of the buttons is, and that's handled once again by the finite state automata class. then we instantiate our audio book SQL data reader object by calling the command object execute reader method, which is pretty much the same as the previous lesson, except this time we also call a function from the finite state automata class called author state, because there's now going to be two types of data that get displayed in the tree. One's author data, either author data unread or author data all the author data, and the other is type data, which is either type data unread or all the type data. So in the case of author data, what we're going to be referencing is the actually within the audio book main table. I sort of didn't do that correctly when I first created the database. I probably should have a separate author table and an author code the way I do with type, but I didn't. I put author directly in the table. And the code we're referencing, if it's type, which is to say it's not author, I essentially just test for author and say if it's not author, it must be type, because those are the only two types we have. So the field we reference, if it's type, is audio book type and also audio book type code, the two fields of the type AB type table. And then each time we call the invoke tree finite state automata method, we close the audio book, assuming we did anything with it, assuming the states changed, so we actually repopulated the tree. And that's so we don't use the same audio book multiple times to repopulate the tree. That'll give us an error. That is to say, the same SQL data reader object, which is audio book. So let's take a look at this new class, the tree finite state machine. The first thing we have in the class is 6 integer constants. They're defined as private const int. And then I by convention usually make them all capital letters and have words separated by underscores so that I can distinguish constants from regular variables. And the difference between constants and regular variables is regular variables, as the name implies, can change value. They're variable. But constants, once you assign it a value in the constant statement, it's that value forever, which allows you to have a good symbolic name for, say, the number 1. If we want the number 1 to represent the author all state, the author without the unread selected. We then have 3 private variables, 2 integers and 1 string. And the first private variable is tree FSM state, for tree finite state machine state. And that's the current state of the finite state machine. The finite state machine, the whole thing about it is handling states. The paradigm actually is more complicated and more elaborate systems. It defines rules for state transitions that say, if the previous state was this, you can't enter this state, but you can enter that state. So this is actually a very simple form of finite state machine. But the point of the finite state machine is the finite state machine, the whole thing about it is handling states. The paradigm actually is more complicated and more elaborate systems. It defines rules for state transitions that say, if the previous state was this, you can't enter this state, but you can enter that state. So this is actually a very simple form of finite state machine. But the point of the finite state machine is to take a complex problem and simplify it. That's the main function of the finite state machine. And then the other state variable is tree FSM previous state, which is the previous state for the state change, assuming there was a state change and it's not the same. And then the last string variable is str SQL, which holds the SQL, which varies based on what state the FSM is in. In other words, what state the radio button and checkbox are in. We then have the constructor for the tree finite state machine, which simply sets the previous state and the current state and the two state values that are outside the system. There are really only 4 active state values. Author all state for the case of author being selected and unread not being selected. Author unread state for the case of author radio button being selected and the checkbox unread being checked. Type all state and type unread state, which is the same thing, only with the type button, radio button selected. So next we have the method that has passed the radio button of author, the radio button of type, and the checkbox of unread, because this is a separate class and those are private variables and controls, so we need to pass those values. And the state changed method is within that if statement. It says if state changed, then do something. If the state hasn't changed, then do nothing, because the tree is already populated the way it should be. And the state changed is really a series of if, else, if statements that look at the radio buttons and the checkbox, and they're pretty much what you'd expect. The first if statement says if the radio button for author is checked and the checkbox for unread is checked, that means the state, which is set into the current state variable, is author unread state. And you know, the next if else checks if the author radio button is checked and the checkbox for unread is not checked. The exclamation mark means not, and the ampersand means and a C# if statement. If those two conditions exist, then the finite state, the current finite state of the finite state machine is author all state. In other words, all the books, not just the unread books, and list the author for all those books. And the remaining two are the same idea, except for the radio button of type being selected rather than the radio button of author being selected. That sets the current state to type unread state or type all state. And finally, the last thing we do in the method is we compare the current state, tree FSM state, to the previous state, tree FSN previous state. And if they're the same, we return false. The reason we return false is we want the calling function to do nothing, because the tree view is already the way it should be. It's already displaying what it should be displaying based on the state of the radio button and the checkbox. And if they're not the same, we return true, meaning we do have to take action. We do need to change the tree view, because the tree view is now out of sync with the radio buttons in the checkbox. And the next method within the tree finite state machine class is the get SQL for state. And this is called within the if assuming that things have changed. And if things have changed, we need to get a new SQL command to be put in the command text of the command object based on what the current state of the radio button and the checkbox is. And if state is author unread state, we pass this SQL statement. And I'm actually going to expand out these SQL statements in a separate file Basically what we're doing within the switch case statement, which looks at the 4 active finite state machine states, is we're assigning a value to strSQL. This initially assigns the first part of it, and then this next statement concatenates another section of the SQL statement. Because the SQL statements are so big, I basically have to break them into parts in order to make them readable. And also there's logical subsections and clauses of an SQL statement, so it's nice to put those on separate lines so you can see what's going on better. So each of these just continues to concatenate to the strSQL string until you finally accumulated all the clauses you need for the full statement. But without the concatenation and all the string activity, these are the statements themselves. And one thing it's nice to do with statements like this is to cut and paste them into SQL Server Management Studio and execute them individually to see if they actually work, to see if you have some kind of spelling error or a syntax error in the statement. But to break the select statement down, the first part says select distinct author, and the keyword distinct is used because we're now looking at the audio books table, which has multiple authors based on having multiple books written by that author. So you might have 20 books written by Stephen King, and if you just say select author, you're going to see 20 instances of Stephen King and the So this statement says select distinct author from audio books where, which begins the where clause, and audio books is the main table within the audio books collection database, and it has a lot of different fields in it. And within the where statement, we want to look at only format types that are of a certain type, and the reason for that is historical on the part of me. I basically have done a lot of saving of books, audio books, and converting of audio books to different formats based on what plays in my MP3 player better. And the final version of MP3 conversion that I invented, really, is I imagine a lot of other people have invented similar ones. I called a Borg. There was ones before it called a Dirk and a Bart. And within the where statement, we want to look at only format types that are of a certain type, and the reason for that is historical on the part of me. I basically have done a lot of saving of books, audio books, and converting of audio books to different formats based on what plays in my MP3 player better. And the final version of MP3 conversion that I invented, really, is I imagine a lot of other people have invented similar ones. I called a Borg. There was ones before it called a Dirk and a Bart. But the Borg format was the most successful. It worked the best. And I could just say format type equals 9 because the number 9 is used to represent the Borg type, Borg format type. But in order to do better programming practice, I create what's known as a subquery, which is a query within a query, so to speak. I say select format type from AB format, which is a table that has the format type number and the string explaining what the format type is. Select format type from AB format where format equals Borg. And this whole statement's just going to return a 9. And as I said, I could hard code a 9 in there, but it's better practice to use a subquery. And if you show this to your manager, you'll probably get more money, which is really the important thing. And then still within the where statement, I say and, which says if the format type is equal to 9 and done is not equal to 1. And I could have defined this as a Boolean, but I actually think back in the dawn of time when I first created this database, there may not even have been a Boolean data type, so I had to use small int. Just say and not done here, the word not spelled out in the case of SQL, if it were a Boolean, but it's not, so I say done not equal, and the less than greater than signed together like that is not equal in SQL. 1. So this is the equivalent of saying not done. And then finally I say order by author, so all the authors will be in nice alphabetical order. Then for the state of author all state, the SQL is identical pretty much, except I no longer have the and qualifier and done not equal to 1, because I'm now looking at all the authors that are within audiobooks and are of this format type. For the type unread state, we have to handle things a little differently, because remember the type table is a separate table from the the audiobooks table. So we need to do what's known as a join. And there's actually several different types of joins in SQL. This is by default, I believe, a left join. And this isn't really an SQL course, so I'm not going to go into it that deeply. But basically what a join does is it takes two tables and turns them into one big table based on a criteria in the case of equijoins, which in this case it says take the AB type table and the audiobooks table and join them on the condition that t.typecode is equal to b.booktype. And you'll notice when I define the tables up here, I say AB type T, and T is what's known as an alias, which is a shorthand form of writing the table name, so I don't have to write out a long thing every time. And I did the same thing with audiobooks. I said B. So this is saying take AB type alias T type code equal to B, which is the alias for audiobooks book type, and when those two fields are the same, join that record together. And it'll probably be a lot of records actually. In the case of Stephen King, or in the case of horror, it might be 100 records joined together based on that criteria. And ultimately it'll be like all the records in both tables that are joined together, although there may be some in one table that aren't in another table, which is the case where you have a left or right join. But now that we've joined the tables together, we can query information from the audiobooks table and use that to select specific type codes from the type table, since they're now one big table. So I say where b.done, which is to say audiobooks done field, is not equal to 1, so it's unread. And then I use the same subquery I used before for selecting audiobook format type. So we just want to look at records that are of format type Borg. And then once again I have an order clause that says order by type, so the types will be in nice alphabetical order. And then the last and final state, the fourth state, is type all state. And that's the same as the one we just looked at, except we no longer care about the done field in audiobooks. because we want to look at all the fields, whether it's read or unread. So if you're really interested in the SQL, and certainly it's at the heart of this whole project to really be interested in the SQL, you might want to freeze pause on some of these SQL statements that are based on the different finite state machine states, so you can really understand them. You know, especially if you're not that familiar with it, it might take some meditating on it before you reach SQL enlightenment on it. So I'd recommend freeze pausing to study the statements, and also I'd recommend playing this over again if you don't get it the first time. The more times you play it, the more times you'll get it. So back in our tree finite state machine get SQL for state method, we're taking the local variable str_sql, and based on the state that the finite state machine is in, and remember that state was set in the previous function, state changed. So state changed and get SQL state work very much as a team. You know, you have to call one before you call the other. So based on each of these 4 active states, we set str_sql to the different SQL statements we just looked at. And the states once again are author unread state, author all state, type unread state, and type all state. And the last thing we do before we leave this method is we set the tree FSM previous state to be equal to the tree FSM current state. And once again, this shows that the two methods are acting as a team, because the previous method is going to check if these are the same, and once we return the SQL, we're saying they are going to be the same. Our calling routine is going to repopulate the tree based on the SQL we're returning, and the tree is going to reflect the way the radio buttons and the checkbox are set. So the radio buttons and the checkbox and the list in the tree view are going to be in sync. So these previous state is now equal to current state until the user changes the buttons or checks or unchecks the checkbox. So we return the SQL to the calling routine, which is now going to use it in the command text property of our command object, which when we do the execute reader method of the command object to create the SQL data reader, it's going to fill in the data that gets used in the tree view based on that SQL. And finally, the last method within the tree finite state machine class is the author state, which basically says if the current state is either author all state or the current state is author unread state, the two possible author states, return true, meaning this is an author state. Else return false, which means it's a type state, and we're going to be displaying type data in the tree, which we need in the loop that's doing a read in the SQL data reader object and putting each record out to populate the tree view. You'll get an error if you try and populate type tree view with author data and vice versa, so we need to call this function. So back in the invoke tree finite state automata local method of the form class, we see the tree command text being populated by the get SQL for state we were just looking at, and then we see the data reader audio book being populated by the execute reader based on that variable SQL. and then we see the function where it checks for author state, and if it is author state, it goes through a loop reading audiobook SQL data reader object, each record in turn, and doing a selected nodes add of the author field in the case of it being an author, and selected nodes add of the type in the case of it being a type SQL select statement. And in this case the tag is set to the type code, and in the case of the author we just select the tag to the author name again. Well, as I said, the invoke tree finite state automata needs to be called from more than one place, and the other places we need to call it from are the radio button author check changed, which will be called anytime you click a different radio button, not just the author radio button but the type radio button too. So we only want to put this with one radio button, or else we'll be calling twice, and or more than twice if we had more than two radio buttons. So the check change calls invoke tree finite state automata, and the checkbox changed. And the checkbox check change also calls invoke tree finite state automata. And in fact, in case of all three of those functions, the before expand of the tree view, the check change of the radio button, and the check change of the checkbox, all we do is call this one local method, which then invokes the methods in our finite state machine class that we've been describing in almost infinite detail, even though it's a finite state machine in this lesson. So the time has come to see if this code actually works. Could this bizarre convoluted code actually do something useful? Well, let's see. Well, this is the running program with our finite state machine class and our invoke finite state automaton handmaiden method in it. And you notice the author radio button is checked and the unread is unchecked. So if we go over and expand the tree, we should see the authors for all the books, whether they've been read or unread, because the before expand calls that routine. Now if we go over and check the unchecked, when we expand the books, we should only see the unread books. And you'll notice Alien Voices and Anderson Kevin, I think, were two books that are missing. If you didn't notice this time, you'll probably notice the next iteration when we start looking at unread things. And we want this to happen not just when we expand the tree, but if we just click a button. So I click type, the tree view changes to the type. And if I click author again, the tree view changes back to the author. And if I click unread, it switches from author all to author unread. And you notice Alien Voices and Kevin Anderson are there. So that concludes the lesson on the finite state machine. Remember until next time that the finite state automaton is out there. It can't be reasoned with. It can't be bargained with. It doesn't feel pity or remorse or fear, and it absolutely will not stop until you focus and learn a lot, or until the previous state is the same as the current state. Hi, I'm popping back for a fifth part of this god-awfully long Alexa07 lesson, Finite State Automaton, because I made a mistake. I said if you have, no matter how many radio buttons you have, you only need to call invoke finite state automaton once. And the fact is, if you have two buttons, only calling it in one of the check change event handlers will work every time, because that one will have always changed. But if you have more than two, you're not sure whether it changed or not. It could have changed or it could have not changed. So the safest way to do it is to create a check changed event for every radio button and put invoke tree finite state automaton call in every one of those. And it won't hurt, because only two of them will get called every time, and the second one won't do anything, because it'll check if the state has changed. It'll discover the state hasn't changed, and it'll just do nothing. So the first call will actually change the list in the tree view, and the second call will basically do nothing every time. So the safest way, as I say, is to create a check changed event handler for every radio button and put that call in it. This is a RATM for the finite state automaton. FALA, and see you next lesson.